All right, ladies and gentlemen, number three. In number three, you notice that there is not a picture or anything, so I'd probably draw a picture really quickly in order to get this. In this situation, I'm going to have my car moving to the right, just crashing into this wall. Big kaboom. And you notice that it's giving you all the information about right before the crash, and then right after as being like, okay, now it is done with its crash. What is going on? So you know the initial velocity going into it. And it comes to rest at the end, so the other piece that I know is my final velocity is 0. So my initial velocity in this case, I believe, was 30, if I'm not mistaken. 20. So that's 20 meters per second. That's 0, and we know that the time frame, the delta t in between these two, or that happened, is 0.8 seconds. So I just kind of draw out the picture, then I'll draw out my force diagram, and you'll notice that my force diagram, Fg, Fn, on the car by the ground. And during the collision, you'll notice that there's an Fn on the car by the wall. So these are the different pieces here, and the first thing I notice is that whole force is my net force in my force diagram. The other piece that I notice is I am given 3 kinematic variables. So you can solve for the acceleration very quickly. V naught is 20, V is 0, delta t is equal to 0.8. And the key idea is you're looking for acceleration. So you do V plus V naught over 2. Oh, no, that's not the one. V equals AT plus V naught. And we have 20, or you would solve this. I'm not even going to do it. You'd solve this to get the acceleration. So that's how you can get the acceleration. And then the next component here is setting up our A is equal to net force divided by my mass of the system. And when I do this, you'll notice that A is known, so we have that net force is Fn on the car by the wall, and the mass of the system is known as the 1200 kilograms. We know this, we know that, we can solve for Fn, which gets us what we're trying to solve for. I believe the other question that is known in the, or that they ask, is how would you change the amount of acceleration, right? I think that's what it asks. Let's double check. Two possible. Oh, decrease the force. In order to decrease the force, you'll notice that the force is governed by this piece right here. So to decrease the amount of force, first off, you'll notice keeping everything else the same. That means acceleration would have to stay the same. In order to decrease that, in order to decrease that, one of the things that you can do is actually increase the mass. If you increase the mass, you'll notice that the force would have to go down in order to keep the acceleration the exact same. So that is one possibility. So if you have a really massive car, the amount of force would actually have to be less in order to keep that acceleration the same. The other situation in this that you can do is you can go in and increase the amount of time for the collision. And this is actually how cars work, because if you increase the amount of time, if we actually went on over here and had V minus V naught over T is equal to A, you're going to notice by increasing the amount of time will actually decrease the acceleration, and by decreasing the acceleration while keeping the mass the same would actually have to decrease the Fn. So you notice that a lot of car makers will actually follow this by increasing the amount of time for a collision, such as airbags, such as a crumple zone, such as I think those are the two. Oh, and then having your seatbelt as well as kind of slowing or increasing the amount of time for that collision, which will decrease the amount of force that would have to cause in that situation. So this is numeral 3. We're going to hit number 4 and number 5 next.